This is Lesson 9, Chapter 1. We are going to learn to estimate roots. Remember, you can use your table as part of this. This would be really handy today. Number 1, estimate the square root of 83 to the nearest integer. So all they want to do is estimate this to the nearest whole number, whether that would be positive or negative whenever we're doing any of these. That's all the word integer means, remember. So what we're going to do is, you could think about this as the square root of 81, the square root of 82, the square root of 83, etc. on a number line, okay? And all we are going to do is figure out, are we closer to the square root perfect square beneath the square root of 83, which of course would be square root of 81, which is 9. Therefore, we have to go to the other side of 83, and the answer for 10 would be the square root of 100. So which is closer? Is it closer to the square root of 81? We're talking about square root of 83, remember? Or is it closer to the square root of 100? And obviously it's much closer to the square root of 81. We don't even need to fill in the rest of the numbers there. And we can therefore estimate it as it's close enough that we can call it 9. So the square root of 83 is approximately 9. Now, one of the things that the book doesn't do that I'd like you to think about is, if you think about the fact from square root of 81 to the square root of 100, it's about 20 numbers. If we put all the numbers in here of the square root, it's about 20. And if we go 2 of those, that's 2/20ths, or 1/10 of the way. So in other words, we can even take a look at this and say, you know what, I think that the square root of 83 is about 9.1. Go ahead and put that in a calculator and you'll find that is exactly what it is. So in other words, what I'm saying is, if you know the square root below and the square root, the perfect square roots below and above a number, you can give a pretty good idea whether it's 9.1, 9.5, right in the middle, toward the high end, like 9.8 or whatever. It's a really good skill to be able to use. The book doesn't require it, but I'd like you to know it. Number 2, estimate the cube root of 320. So we have to take a look at our cube root chart, and we have a cube root of 216 would be below 320, and the cube root of 343 would be above. And now we have to figure out which is closer, 216 to 320 or 343. And clearly it is closer to the cube root of 320 is closest to 343, therefore it's closest to 7. Please press pause and do letters A through F. Okay, for problem number 3, Wyatt needs fence for 2 square meters of land. Okay, so we have a square, 2 square meters. Okay, therefore we know that it is the square root of 2 on both sides, because square root of 2 times the square root of 2 would give us the 2 meters. Okay, and perimeter says that we need to get this, 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 and this, all 4 sides together. Well, since they're all the same, we can just do 4 times the square root of 2. Put that in a calculator, and that equals 5.65. In your book, they have you do 3 sets of estimations. We are not going to do those problems. I'm going to be frank with you. The big reason that I'm not going to do that, just as I showed you on the previous problem where we can estimate a square root, those types of things are very valuable in life. But in this particular case, on this problem, there's no way somebody's going to go through all that work to try to figure out how many feet of fence we need, because quite frankly, almost every human being carries a cell phone with them, and most cell phones have this function. You can do 4 times the square root of 2 on your cell phone and find out that you need to buy about 6 feet of fence. Okay, so we will not be doing the 3 sets of estimates on all the problems in this lesson where they ask for that. We are not going to do that. We're going to actually use a calculator and just solve the problem. Here are your solutions to 1-9, your letter problems. We are being asked to solve to the nearest integer. So we have the square root of 35. We take a perfect square root below. Square root of 25 would be 5. And one above, square root of 36 is 6. Obviously, square root of 35 is much closer to square root of 36, so our answer is approximately 6. Letter B, we have the square root of 170. We go below, square root of 169, that's 13. The square root of 196 is 14. We're much closer here, so our answer is 13. Letter C. Again, you should be using your table for these. That is the easiest way to find these. That's one of the biggest reasons I had you create the table. Square root of 44.8. So we have the square root of 49 above and the square root of 36 below. We're closer to here, so we have 7 for an answer. And lastly, letter D, we have the cube root of 62. So our perfect cubes are the cube root of 27 and the cube root of 64. Much closer to 64 with the cube root of 62. Therefore, our answer is 4. Letter E, cube root of 25. Below that, we have the cube root of 8, and above it, we have the cube root of 27. This is 3 and this is 2. Much closer to the cube root of 27, so we use 3. Letter F, we have the cube root of 129.6. Below that, we have the cube root of 125. Above it, we have the cube root of 216. Again, we're much closer to here. Cube root of 125 is 5. Please do guided practice. Pay very close attention to this. For problems 7 and 8, use your calculator and get an answer to the nearest tenth. Do not do the 3 sets of estimation that they taught, but I want you to know how to do these problems. Just use your calculator. Here are your solutions to Lesson 9, Chapter 1, Guided Practice. First problems, we're asked to estimate to the nearest integer. We're estimating the square root of 28. The perfect square below it is the square root of 25, and above is square root of 36. Clearly closer to 25, so the square root of 25 is 5. Our answer is 5. Problem number 2, the square root of 135. Below we have square root of 121 and above 144. 135 is closer to 144, so we go with 12. Problem number 3, square root of 38.7. Below we have the square root of 36 and above square root of 49, much closer to 36, so we have 6 for an answer. Now we switch to cube roots. We have the cube root of 51. Below we have the cube root of 27, above the cube root of 64. 51 is much closer to 64, so we go with 4 for our answer. Problem number 5, cube root of 200. Below we have cube root of 125, above cube root of 216, much closer to 216, so we go with the answer of 6. And number 6, cube root of 95. We have the cube root of 64 here or below, and we have cube root of 125 above, closer to 125, so we go with 5. Number 7. Remember, we're going to do this without all the estimating. We're just going to solve the problem. So Tobias drops a tennis ball from 60 meters. And in physics, there is an equation for that. The time it takes the ball to drop is 0.25 or 25 hundredths or 1/4 of the square root of the distance in meters that it dropped. So we're going to use the square root of 60 here. Just put it in the calculator. 1/4 of the square root of 60 is 1.9 seconds to the nearest tenth. Number 8. Now we have a swinging pendulum, and the number of times the pendulum will swing back and forth has been calculated. Again, we have a physics equation for that. It's 375 divided by the square root of the length of the pendulum will give you the number of swings. I forgot to put that over here. So we have 375 divided by the square root of 40, because we have a length of 40 for the pendulum. Therefore, it will swing about 59.3 swings. And finally, our essential question: how can I estimate non-perfect squares? Well, first of all, step number 1 is you have to know your squares. If you know your squares, you can therefore pick a perfect square below the one you're looking for and one above the one you're looking for, and then it's a matter of determining which one is closest. And I would say, better yet, interpolate. Interpolate, what that means is, remember back on our very first problem we had, I believe it was the square root of 83, and we figured square root of 81, and the square root of 100. This was 10, this was 9, And we figured, well, let's see, this 83 is about 2 out of 20 numbers, or 1/10, so the square root of 83 is not only 9, we can estimate it as 9.1. That's what interpolate means. Interpolate means to estimate how far we are from one thing to another, and then come up with a number as close as we can. So without calculating this, we had that as 9.1, which is indeed correct. This is the best way to do it. Thank you.